page 588, and you look here at C, and it says, describe the transformation you can use to map the vertices of garden RST to the corresponding garden DEF. So everything is has gotten smaller. So we're going to see in a minute, when it gets smaller, it has to be a fraction. And if I look at R, it was at, well, -4, -2. And now D is at -2, -1. And so it's decreasing by a half. And so that means the scale factor equals 1/2. And then if you look down at the bottom of this page, it tells you right here, you can represent dilations using the coordination XY goes to KX and KY, where K is the scale factor and the center of dilation is the origin, okay? So K is the number that you're multiplying X and Y by. It's the scale factor. And if K is a fraction, okay, it says if 0 is less than K and K is less than 1, that means it's a fraction. It's somewhere between 0 and 1. The dilation is a reduction. And if K is greater than 1, the dilation is an enlargement. So if we look here and it says map RST to XYZ, there must be some factor K that dilates to the RST, that dilates RST. So if we look here and we notice R goes from 0 to 1, and X is 0 to 3, and S 1 to -1, 3 to -3, we can write this like XY goes to 3X and 3Y. And they always have to be the same. What you do to X, you must do to Y for it to be an even dilation. If those aren't even, it's not going to, all the pieces aren't going to get large at the same factor as the other ones. So our scale factor in this example is 3. Okay, so let's consider this graph at the top of the page. This is page 602. Jump to 602. And if you look at this, it asks, we're going to look at these two graphs, and it wants to know if these angles are congruent. And those are two rectangles, and we know in rectangles that all the angles are 90 degrees. And so, yes, those are congruent. Okay, and so now we're going to look at the side lengths. And so the first one, now notice that these lines go by 2. So if I measure AB, it's 2, 4, 6, 8. And EF is 2, 4, 6, 8, 10, 12, 14. And if I simplify that, I get 4/7. And I want you to pause this video and do the other 3 by yourselves. Okay, so after you're done with this, they simplify. When they simplify, you can see that these ratios are not the same. And so these figures are not similar because their sides are not proportional. Their side lengths are not proportional. They have not all used the same scale factor to increase, okay? And that's what that means. The other way that you can use to see if these are similar is, I'll make this big, is what we did in class on Friday. So from the origin, if I draw a line between those two vertices that are corresponding, okay, and then I do it from these two, you can see that they do not have the same center. They're not going to start from that same O that we drew on Friday. Okay, so this is probably going to be the hardest part of these two lessons. And what we want to do is we want to find a sequence of transformations to get from one of these shapes to the other. So the first thing that I am going to do is to get it the same size. And now the problem with this one is that RP does not start at the origin, okay? And because it doesn't start at the origin, we can't just do the points, like multiplying x by 3. What we have to do is check the length of each side. So this length is 1, 2, 3. And this length is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the scale factor is 3. Okay, so this was 3 and this was 9. So I know that I have a dilation by a scale factor of 3, and I'm going to use K. And I'm going to say x, y goes to 3x and 3y. So that's the first thing we have. Now, I think it would be helpful if you actually draw this dilation centered from the origin, okay? And so J is 1 from the origin, and so my new one is going to be 3 from the origin. 1, 2, 3. Okay. K is up 2 over 1. Oh, and I guess let me label this J prime. So K is up 2 over 1, and so I need to perform that 3 times to get K moved. So up 2 over 1, up 2 over 1, up 2 over 1. And there's my K prime. L is up 1 over 3. So I'm going to perform that 3 times. Up 1 over 3, up 1 over 3. Did I do that right? 1, 2, 3, yes. Up 1 over 1, 2, 3. And that is going to be my L prime. Okay, so now I drew the triangle. Now that they're the same size of my final triangle, is the same size as this, I can try to get them into the same place, okay? And so it looks to me like the first thing we need to do is, or actually the second thing we need to do is a reflection across the y-axis. And when we do that, 1, 2, 3, 1, 2, 3. I'm going to do this one in red. And L is 1, 2, 3, 4, 5, 6, 7, 8, 9 over. So 1, 2, 3, 4, 5, 6, 7, 8, 9 over. And I want to write that, that xy becomes negative x, y, doesn't it? Even though we don't have our little cheat sheets, it's easy to see that. Then finally, we need to rotate it and move it up. So if I moved these points, that would move there, Q would move here, and J would move down here. That is a rotation of 90 degrees. Clockwise, right? And let's check what those points are. This point is -9, 3. And up here, R is 3, 9. And so it's going to be XY goes to, whoops, I'm sorry. Yeah, it's going to be so what is that? It would be Y becomes X, and then opposite X. And that is where we'll spend most of our time Monday on homework, is getting this, because I think these things are the most confusing. So have a great weekend, and we'll see you then.